In the previous video, we saw one type of problem, correct? So where the words have been interchanged, the letters have been interchanged. Now we'll do one other type of problem where we are going to use combination. All right, look at the first one. A group consists of 4 girls, 7 boys. In how many ways can a team of 5 members be selected if the team has, so sub questions are there, correct? So first what we'll do, we'll look at 4 girls and 7 boys, right? So we have 4 girls, 7 boys. And how many should be there in a team? 5. So we need to have 5. 1, 2, 3, 4, 5. Remember, grouping, selecting, choosing, all these things, they are combination type of problems. All right. So in this one, so in how many ways can a team of 5 members be selected if a team has no girl? That means it's all boys. The first one is going to be all boys. No girls is the same as this. So out of 7 boys, we need to select 5 or we need to choose 5. So we can say the first one answer, all boys combination, right? 7C5. If you remember, NCR is the same as NCN minus R. So 7C5 is the same as 7C 7 minus 5, which is 7C2, which becomes 7 into 6 divided by 2. So 21 combinations. So the first one is going to be 21. All right. Now second one. See, for the second one, at least one boy and one girl. Now this is a little, I would say, it's a little extension type of a problem, in the sense, at least one boy, meaning there can be more than one, correct? And they say at least one girl. That means it can be more than one girl. Rather than doing this, the reason why we say rather than, because, so how many combinations are you going to take? Huh? So one boy, 2 boys, and then one girl, 2 girls. Like, how many combinations will you take? That itself will take a lot of time. So what we do, we take the total way, total combination, and subtract the cases where it's not possible. That way it's much more easier for us to solve it. Fair enough? See, the question is what? At least one boy and one girl. So both should be there. In other words, I can say there has to be one boy, there has to be one girl. Minimum. What if I take the case where there are no boys? Okay, but that is not possible because there are only 4 girls, correct? There are only 4, but we have 5 places. That means one of them has to be a boy. Makes sense? But there is one case where no girls can be included. So there can never be a case where there is no boy in the group, because out of 5 there are only 4 girls. The 5th one has to be a boy, isn't it? So what we are going to do, we are going to eliminate the case where all of them are boys, because that at least one girl, see here, this one girl condition is going to get eliminated, right? That will not be satisfied. So what we are going to do now is total number of cases minus where all the combination, like the combination where all of them are boys, will subtract. So first we'll take the total number of ways. So total number of ways, that means here, what are we going to take? We are going to take every possible case. That is, out of 11 students, 5 has to be selected, correct? How do we get 11? 7 plus 4. So total number of ways is 11C5 minus 7C5. You might be thinking, how 7C5? Look at the first one, all boys combination. So 11C5 minus 7C5. 11C5 would be 11 into 10 into 9 into 8 into 7 divided by 5 into 4 into 3 into 2. into 1 minus, see 7C5 is 21. We have already done that before, correct? Now we'll divide this. 5 into 2 is 10. Then we have 4 twice, 3 3 times, right? So 33 into 14 minus 21. Okay, so this is going to give you an answer of 441. So the number of cases where at least one boy and one girl will be there is going to be this. Fair enough? This is the final answer. So this is the answer for the second one. Now we'll go for the third one, at least 3 girls. See the case, at least 3 girls. So we have how many places are there? 1, 2, 3, 4, 5. Of which minimum 3 girls should be there. So 1, 2, 3. 3 girls are fixed. At least 3. There's only one more possibility. That is, another one has to be a girl. Correct? And the next one has to be a boy. Because there are only 4 girls. Out of 5 places, 4 girls will be there. So 2 cases you will have. Okay, 2 cases you are going to have. The first case, case 1, is where 3 girls are there, 2 boys are there. Correct? Or case 2, 4 girls, 1 boy. Right? Very simple. When you take 3 girls, there are 4 girls in total. So it's going to be 4C3. Out of 4 girls, we are choosing 3. 4C3 into how many boys are there? 7. 7C2. This is one case. Second case, 4C4 into 7C1. So 4C3. So the first case, 4C3 is 4 into 7C2 is 21. Correct? 4 into 21. This is going to give us 84. Next, 4C4 is 1 into 7, which is equal to 7. So total number of cases will be 84 plus 7, which is going to give us 91. Fair enough? 91. So the answer for the third one is going to be 91. So many cases are there. Fair enough? This is the answer for the first one. Now we'll go for the second one. Look at the question. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2. So we have 12 divided into 2 parts, part 1, part 2, containing 5 and 7. So it has 5 questions, it has 7 questions respectively. Fine. A student is required to attempt 8 questions. So out of 12, 8 in all, selecting at least 3 from each part. In how many ways can a student select these questions? It's very similar to the last problem what we did. So at least 3 from each part. Of course, different cases will come, isn't it? So at least 3, correct? So what if I choose 3 questions from the part 1? So case 1 is going to be 5C3. That means I'm choosing 3 from the first part. That means the rest of the questions has to be from the second part, isn't it? The rest of it is going to be what? 7C5. Because 3 plus 5, total of 8 questions should be there, isn't it? This is the first case. Next, case 2 will be 5C4. That means out of 5, I choose 4. The remaining 4 has to be chosen from the second part. Right? Next, case 3, 5C5, 7C3. Correct? So when they say at least 3 questions from each part, so we are using the same thing, isn't it? So first case, 5C3. 5C3 is the same as 5C2. So this is going to be 5 into 4 divided by 2 into 7 into 6 divided by 2. 7C5 is the same as 7C2. Correct? NCR, the formula what we are using. NCR is equal to NC N minus R. We use this formula. Fair enough? So this is going to be 2. This is going to be 3. So 10 into 21. So 210. Okay, this is done. Second one, we have 5C4 is the same as 5C5. Sorry, 5C4 is the same as 5C1. Right? 5C1, which is nothing but 5. Into 7C4 is the same as 7C3, which is 7 into 6 into 5 by 3 into 2. Cancel, cancel. So we get 5 into 35. Right? Last one. 5C5 is 1 into 7C3 is 35, because just now we did it. 35, which is going to be 35. So what do we get in total? We get 210 from the first one plus 35 times 5, which is 175 plus 35. Correct? So the total number of ways is going to be 420. So the number of ways a student can select the questions is going to be 420. Fair enough? So this is how you solve these type of questions where you need to take different cases and do it. Fair enough? Let's do the third one. Look at this question. In how many ways can the letters of the word assassination be arranged so that all the S's are together? So first, let's look at the number of letters, how many we have. This is very similar to the previous video, whatever we have done. So first, so we have 1, 2, 3, 4, 5, 6, INATION, correct? So these many number of letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in total, there are 13 letters. 13 letters. Now the condition is what? The condition is all the S are together. Correct? Since all the S should be together, how many are there? 4. Correct? So we'll make sure that all 4 S are together. Now you tie them up. Imagine like a rope, an imaginary rope. You're tying all the S together. That means we have one S here. That's all. One letter, one special letter. 1. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, so this entire S's are collected here. Then the rest of the letters. So you have A, I, N, A, T, I, O, N, all of them. Fine. So in total, we get 9 letters. 9 letters. Correct? So since all the S's are together, next what is the thing we need to do? Total number of combinations or total number of arrangements. Now we have 9 factorial by how many letters are repeated now? So if you look at this, A 1, 2, 3 by 3 factorial, correct? Next, I is repeated twice into 2 factorial. Next, N is repeated twice into 2 factorial. So answer is going to be 9 factorial by 3 factorial into 2 factorial into 2 factorial. Fair enough? So this is going to be the total number of arrangements of this particular word. Fine? We'll do the next one now. See the question. Determine the number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards has exactly 1 king. Alright, so we have 1, 2, 3, 4, 5. Out of these 5 cards, 1 king has to be there. Correct? And that to exactly 1 king. There cannot be any other kings whatsoever. That means 1 king place is fixed, correct? So I would say that, okay, this place is fixed. I can no longer take any other kings anymore. So out of 52, there are 4 kings, correct? So 2 in the black, 2 in the red. So out of 4 kings, 1 king is gone. So how many kings are there? 3 kings are there. But can we take those 3 kings into even consideration? No, right? So out of 52 cards now, since K can be eliminated, total number of cards, is going to be just 52 minus 4, which is 48, right? So 48 cards are available to us. Out of 48, how many are there now? So we have 1, 2, 3, 4. So we need to choose 4 out of 48, isn't it? So we can say the number of combinations, this is going to be 48C4, which if you expand 48 into 47 into 46 into 45 divided by 4 into 3 into 2 into 1, which we can further simplify. That is, see, 4 into 3 is 12, 12 into 4 is 48. Next, 2 into 2. So the number is going to be quite a big number if you look at it, because we have 47 into 46 into 45 into 2, correct? So the answer is going to be 194,580. That's 1,94,580. So the number of combinations for this particular question is going to be this. Understood? So the answer is going to be quite a big number. And if you look at it, whenever we look at two different types of questions, that is either the deck of cards or whenever we are doing movement in the chessboard, the numbers are generally quite big. Fair enough? So these are certain types of questions what you can look into it, and these are different types of questions in combinations.